Hi there, Miss Lambs here. Today we'll talk about microbiology part 2, which is the pour plate method. So what is pour plate method? Pour plate method basically involve counting bacterial colonies. So this is just a brief overview of how do we do the pour plate method. So first of all, on a sterile petri dish, you will add your microbes. Okay, you add a bacteria, then you add your antimicrobial substance, such your IV. Okay, and then with a micropipette. Okay, then you add some autoclaved agar, and we recommend 10 ml of the agar. And then afterwards you mix it. Okay, and then you let it cool down to form the plate for 24 hours. Okay, and then you check for the bacterial colony on the plate. Okay, sometimes we use the colony counter if it's too small to see. So this is a link of the pour plate method, but because of copyright issue, I cannot play it here. So what you can do is you can pause the video and access to the link, or I will put this in the video description below. Okay, so you can watch this later. Okay, so pour plate methods. Okay, so what will it looks like? So for example, the red part on the left, okay, is the ones with the inhibitions. Okay, actually I use lead nitrate in this case, and then the yellow part here is the control, where I will use distilled water, sterilized distilled water. Okay, and so let's take a look at some of the plates. Again, microbiology, this is examples of failures inevitable. Okay, so out of the 4 plates that I have used, okay, some of the plate could be contaminated, some of the plate cannot be used, because for example in this case, in the top right ones, okay, hold on, let me just check if I have got this annotated. Spotlight, okay, spotlight, okay. All right, so here, this one, okay, you can see that actually instead of forming bacterial colonies like this small dot, this plate actually start to form biofilm, okay? So biofilm, so even if I use the cell colony counter with the light background, okay, you cannot see any much result. Whereas these ones seems okay, okay? So you can see that these are the colonies there. Okay, so you can count the colonies here and so on. But occasionally there's some contamination. So there's some mild contamination. As you can see here, there's an irregular patch. So this could be formed by molds or anything. Okay, because mold is actually reproduced by spore, and spore could be quite heat resistant. Okay, so what can we do? Okay, so out of 4 plates, maybe 2 of the plate doesn't work very well. So again, so you need to mentally prepare yourself that in microbiology, there's a lot of failures along the way, even if you do all the procedure right. Okay, so usually if let's say if your IV is discontinuous, so for example with lead nitrate and without lead nitrate, you can see that you need to run a t-test, and for t-test you need 10 repeats. So generally speaking, I will advise my students each time when they do it, they need to make like 15 plates in case some of the plates did not work, so that at least they have 10 plates of result that they can count on. Okay, so yes, and then this is the control with distilled water. Next one. Okay, so this one is with the lead nitrate, and I also add a red color dye into it so that it's easier to see. As you can see, okay, I put a generous amount of lead nitrate here, so it actually is mostly inhibited, so it's quite clear plate. But here you can see there's a occasional one dot here and another dot here, there's some dot here. Okay, so there's some result, but this type of result is also not preferable. We prefer to have some result but not totally no result. Okay, so again, if this is an IV, then IA or experiment project, then I will recommend students to adjust their lead nitrate concentration a little bit more as well. Okay, so there you go. So there are some plates here. Okay, so what are we expecting? So for example, let's say this one is the with the lead nitrate, and then this one is the control with distilled water. So this is acceptable. Okay, so you can expect that the control will have a higher number of bacterial colonies, whereas the lead nitrate one could be slightly less number of bacterial colonies. Generally speaking, one more thing is that we prefer a plate that has not more than 200 bacterial colonies. Because if you have more than 200 bacterial colonies, then that might not be very accurate. Yes, 200 colonies per plate. Okay, so that's what we want. Okay, and another idea for you to see is that, okay, so for I copy from the internet. So here there's like 3 concentrations of bacterial concentration, and this is the most diluted one, okay? This most diluted one, you can see there's less bacterial colonies, okay? And then this one is much more, okay, so 10%, no, 10 times more bacterial colonies. And then here there's like even more 10 times more. So there's like 100 times more, okay, yeah, 100 times more. So here, instead of forming individual colonies, okay, it seems like they start to form a biofilm. So here, another better diagram, you can see that, okay, so there's too much colonies to be counted. So when that is the case, if you allow it to further develop, eventually it will develop into a biofilm, okay, which is not suitable for the pour plate method, okay, you cannot collect data. Yeah, so here this is like another more 10 times more diluted, and then even 100 times more diluted, and we prefer this one, okay? Just curious, okay, so this, in this diagram, you can see that actually there's more than one more than one microbes, okay? As you can see, another thing about qualitative observation, that means the word observation, when you describe the plate, not only to describe, like for example, a pattern such as the colony density, the colony size, the edge, and things like that. So here actually there's in this picture, it's possible that there's 2 types of microbes here, okay? Same here again, some of them, but it's not very clear. It's easier to see on the most diluted one as well. Okay, so moving on to next one. Okay, so this another video, another picture from the internet, so suggesting what is regarded as a good plate. So here there's too many colonies, it start to form biofilm. Okay, so actually the colony merge together to form a biofilm. So again, this is not a good one. So this one is too much as well. So on the glance, it's more than 200 colonies. So again, too hard to count. So we'll recommend students, if you see plate like this, then we'll recommend you to dilute your bacteria furthermore. Okay, so this was manageable, still acceptable. Okay, yes, but this is the best one. Okay, so not a lot of bacterial colonies, is easier to count. Okay. So troubleshooting. So like we said in the previous video, in microbiology, we do a lot of troubleshooting. So sometimes the plate is too clear, okay, then that's not what we want. Sometimes the plate is too much bacterial colonies, that's not what we want. So what can we do about it, okay? So let's look at how we can do it. So for example, let's say this is a method modifications. So originally, you add your your IV, okay, antimicrobial substance, okay, and then your bacteria and then your agar. So that's the sequence, okay? But turns out that your plate is clear, okay? So nothing is on, no bacterial colonies after 24 hours. Let's say, let's give it a reasonable time. So 24 hours is a reasonable time. So at 29 degrees Celsius and after 24 hours, okay, so it turns out it's a clear plate. Then it could be because the IV was very strong, okay? So it kills bacteria before growth. So what we did is like, we adjust the procedure a little bit, okay? So for example, we add bacteria, then we add agar, okay, before we add the IV. So instead of having everything together and agar the last step, we put agar in the second step. The reason is because if you add the IV with the bacteria first, okay, then perhaps the IV is too strong, then it's possible that they kill the bacteria before the bacteria can grow on the agar, okay, on the nutrients agar. So that's the adjustment that we made. So for example, add bacteria, add agar, add the IV, and then you mix well with the cell spreader. So how do we know if the IV is too strong? So for example, the cover of the plate shows chemical corrosion. So in the case of, for example, some of the essential oil. So for example, some of the essential oil that's too strong after overnight, okay, when you observe the plate, after you use a towel to dry the condensation, it seems like the plate is still translucent, okay? Then it's not transparent and no longer clear. It's possible that the vapor, because the essential oil could be very volatile, the vapor is already have a chemical corrosion on the plate. So of course the bacteria will not survive that ordeal, okay? So that's why we need to adjust the step a little bit, okay? Another one is water or agar too hot and kill the bacteria. Again, so usually when you watch the video online, they recommend that, as long as you touch the bottle, it doesn't feel hot, it's okay to mix with the bacteria. Based on my experience, it's better to also use a thermometer to check. Generally speaking, you're looking at like 35 to 40 degrees Celsius before you mix the bacteria. Then that's a safe temperature to mix it with bacteria. And also I checked online as well. So for lactobacillus, which is the common one that we use, the highest temperature they can obtain is like more than 40, slightly more higher than 40 degrees. So 40 degrees should be fine. Okay. Or another reason why for clear plate is because there's not long enough incubation time. 8 hours, 12 hours, okay. But in some cases, it's always good to occasionally check if possible. But if not possible, 24 hours is a very good incubation time. And next one is bacteria was not stirred before extracting. We've mentioned it in the previous video, especially when you are doing a very diluted bacteria concentration. It's possible that the bacteria sediment at the bottom, and if you didn't stir it before you extract it, then it's possible that there's not enough bacteria at the start. Another one, okay, so another possible method, if there's too much, if let's say clear plate, there's these possible reasons and what we can do about it. And the next one is if there's too many colonies, so you're looking at like more than 200 per plate, or if you see some irregular patch, as we mentioned here, it's possible that there's some mold or contamination. Then what can we do about it? We need to think about the reasons. So for example, some of the IV source, so your antimicrobial substance, may have bacteria on it. So a very common case that we experience is that sometimes some herbal tea, okay, so naturally they will have some bacteria on it, okay. So how can we overcome this? So this time we try that we add the IV, okay, so for example, herbal tea with the agar, and then we ask our lab technicians to help us to autoclave it, okay, so make sure that it's sterile before we mix it with the bacteria, okay. Now again, so you can see that this is the importance of negative control. So how do we know that actually the bacteria is coming from the tea rather than coming from the probiotics? It's because the students have tried to do the negative control to check that actually, if they mix the tea with the agar, is there any bacterial growth? And turns out that is. So there could be something wrong here. Another one is, okay, if you have too much bacterial colonies, okay, so you can adjust the concentration of the bacteria, or you can increase your IV concentration, or decrease the incubation time. So that is where the 8 hours, 12 hours comes in handy. Okay, so these are the possible way to overcome this problem. Again, of course, there's also a stricter antiseptic technique. So for example, you should flame the bottles before you start, okay? So you should work near the ethanol lamp, okay, or maybe in the laminar hood, okay, things like that, flow cabinet. Okay, so and the next one is I would recommend students to have a record, okay, have a record of as to keep record of your step, what works, what did not work. So for example, I have purposely blank out this IV because I want you to try for your own experiment. So your bacteria source, okay, so what bacteria concentration have you tried? So and then they try the IV concentration, IV volume. So this one usually we use 1-to-1 ratios in terms of volume. And then agar concentration is made, okay, so fixed, okay. And then incubation time, generally speaking, 1 day. Incubator 29 degrees Celsius, okay. And then the result, okay, so your comments on the plate. So generally speaking, and then your conclusions and what actions taken. So it's always good to have a record of things, and then what works and what did not work, okay. So that it helps you to write your IA or EE, okay. So, and also how does it help is because it will justify, or help you to justify why you are using certain concentration or volume, okay. So yep, moving on. So that's about it for the pour plate method. So I hope this video helps you in your writing up your report, or when you plan out your experiments, when you face failure. Hope that helps, okay. So at all, and don't give up. Thank you and bye-bye.